In this video, we're going over questions that talk more so about preparing solutions and the type of calculations you'd need to do that if you were in a lab and needed to figure out how much you need of your solute in order to create a solution in lab. So let's say, for example, we're asked to prepare 100 milliliter of 0.200 mole per liter solution of copper 2 sulfate. So I'm just going to adjust this so that it's got the correct subscript number after oxygen. So outline the steps involved and include all calculations. Here's our materials. We got wash bottle, funnel, dropper, beaker, volumetric flask, and a balance. Alright, so first off, I'm just going to start with calculating the required mass of solute, and then I'll talk my way through the rest of this here. Okay, so what we're given here, we're given volume, which is 100 milliliters, and then we're given concentration, which is 0.200 mole per liter, and that looks to be it. Okay, so in order to figure out mass, we'd have to use this mass is equal to moles times molar mass. Okay, and since we've been given the identity of the substance, we know it's copper 2 sulfate, we've already been given molar mass. Okay, but right now we don't have moles, but we've been given volume and concentration, and we know that the formula involving both of those variables is concentration is equal to moles divided by volume. And if we isolate for moles by multiplying both sides by volume, okay, we get volume multiplied by concentration is equal to moles. So if we use this formula first to figure out moles, then we can plug in the value we get for moles into our mass formula. Okay, so that's going to be my game plan here. And another thing I'm noticing that I need before I'm going to get everything started is I need molar mass. So I'm just going to do that quickly up here. So the molar mass for copper, that's 63.55 grams per mole. The molar mass of sulfur, that's 32.07. And then the molar mass of all four oxygens is going to be 64 grams per mole, because the molar mass of an oxygen atom is 16. 16 times 4 is 64. So if we add all of those together, we get 159.62 grams per mole. So that is our molar mass there, which, just to save me from scrolling around, I'm going to write down here. So 159.62 grams per mole. Alright. Another thing I'm noticing before I get started is obviously our units for concentration is mole per liter, but notice how volume is in milliliters. So I'm going to want to convert milliliters into liters first, just by dividing by 1,000. So that's going to give me 0.100 liters for my volume. Alright, let's get started here. So moles is equal to volume times concentration. Volume is 0.100 liters. Then we have 0.200 mole per liter. The liters are going to cancel out. So we're left with 0.01 moles. I haven't put this in the correct sig digs, and it's just because it's not my final answer, so I'm not going to worry about sig digs right now. Okay, so now that I have moles, now I'm going to figure out mass. So let's do that in a different color. Mass is equal to moles times molar mass. So we have 0.01 moles times by, actually I'm going to make it like that, and then our molar mass was 159.62 grams per mole. All right, so moles cancels out. And what we get is, whoop, just kidding. All right, so liters cancels out, and we get 0.02 moles. Okay, so I'm not going to worry about sig digs right now, just because it's not my final answer. But let's continue our calculations up here. So mass is equal to moles times molar mass, and actually let's just put this in a different color there. Hang on. Boop. There we go. Okay. So we have 0.02 moles times by 159.62 grams per mole. So cancel out moles, and we are left with 3.1924, and that's grams. All right, so looking at my given numbers here, we have 3 sig digs and 3 sig digs. Reminder that leading zeros don't count for sig digs. Okay, so I need to put, this is 3 sig digs. So there's my 3 significant digits. So my final answer is 3.19 grams of copper 2 sulfate. All right. So essentially, if we were in a lab, we would figure out, okay, we need 3.19 grams of copper 2 sulfate weighed out. And what we'd do is we'd take a beaker and we'd put it on a balance, and we'd weigh out that 3.19 grams of copper 2 sulfate. Then what we'd do is we'd take a wash bottle just to add water into the beaker that has the copper 2 sulfate, just enough to dissolve it there. And then once it's fully dissolved, then we would take the funnel and put it on top of this volumetric flask and pour the solution that we made in the beaker into the volumetric flask. And then we would add more water to fill it up to the little line that would be on the volumetric flask here. Now the reason why we would finish making this solution in a volumetric flask is simply because volumetric flasks are incredibly accurate instruments. So essentially the whole point is to make a solution of a known concentration, and how you do that is by using an incredibly accurate item such as a volumetric flask to create the solution. Okay, and once you have that solution created, then what you'd do is you'd put a stopper in the top, and then you would invert this volumetric flask. So you'd kind of flip it around about 10 times in order to mix the solution properly so it has the same concentration throughout. And there you would have your solution of 0.2 mole per liter of copper 2 sulfate. Okay. So that's about the basics of how you would create a solution in a lab there. Okay, let's move on to some more practice problems here. So describe how you would prepare a 1 liter of a 1 mole per liter solution of sodium chloride. The molar mass of sodium chloride is 58.44 grams per mole. Okay, I'm going to adjust these numbers just for some more sig digs here. Okay. All right. So make sure you make those adjustments so your final answer makes sense. Let's create a list of givens here. We have our volume as 1 liter, our concentration also as 1, but this time it's mole per liter, and we're given our molar mass, that's that 58.44. And that's grams per mole. All right. So essentially, we're just going to be doing the same strategy that we used here. So step 1, we're going to find our moles of sodium chloride. Step 2, we're going to find our mass of our sodium chloride. Okay, or to make the steps a little bit more general, find your moles of your solute, find your mass of your solute. In this case, it's sodium chloride. So step 1, find moles of solute. Remember, the solute is what you have less of, and it's the thing that gets dissolved. Okay, so moles is equal to volume times concentration. We have 1 liter times by 1 mole per liter. Liters cancels out. And we're going to get 1 mole. Okay. All right. Now step 2. Find mass of solute. So this is where we use mass is equal to moles times molar mass. So our moles, that was 1 times by 58.44 grams per mole. So moles cancels out, and we get 58.44 grams of sodium chloride. So 58.44, since I put these two numbers to 4 sig digs, this is already in the correct amount of sig digs. Just as a reminder, since molar mass is a constant, you never use constants to determine your however many sig digs you need your final answer in. So if we're describing how we would prepare the solution, now that we know how much we need to weigh out, now we can write out our answer. Okay, so what I would say is take a clean, dry beaker, put it on a balance, weigh out 58.44 grams of sodium chloride. Then put in enough water to dissolve the sodium chloride. However, we wouldn't want to use 1 liter of water because we got to make sure that we don't overfill our volumetric flask. Okay, so I'm going to say 0.75 liters or less. Then transfer to a volumetric flask using a funnel. Continue filling volumetric flask with water. Up to the fill line. Then stopper flask and invert 10 times. That's how I would create this solution if I was in a lab. Okay. For the next example, describe how you would prepare 100 grams of a solution that is 0.5% phenolphthalein by mass. So with this is a percent mass by mass calculation that we need to do. So how I know it's percent mass by mass is because it says by mass, and also it says that we have 100 grams of our solution. That's how I know. Okay, so mass of solution is going to be 100 grams. Percent mass by mass, we were told that that was 0.5%. Okay, and it's asking for us to figure out what is the mass of the solute. Okay, because that's the only thing that we don't have. As a reminder, the formula for percent mass by mass is this. So percent mass by mass is equal to mass of the solute divided by mass of the solution times by 100%. Okay. So what I find easiest to do in formulas that involve percentages is first just to plug in the numbers and then rearrange the equation there. So 0.5% mass of the solute, we don't know. I'm just going to keep it as a little m. Mass of solution is 100 grams, and then we're timesing that by 100%. So how I would rearrange this equation here is I would try to isolate this fraction here first. So how I can do that is I notice that the 100% is multiplying this fraction. So then I would just divide both sides by 100. If you're wondering why I don't just take 100% and divide it by the 100 grams just to isolate the m, I could do that, absolutely. However, I'm trying to give you some more general steps that will help you out when you don't have nice numbers like this given to you in your question. Okay, so 0.5% divided by 100, that's going to be 0.005. Mass divided by 100. So 100 is dividing into mass, so we gotta multiply it. 100. So then we're given 0.5, and that'll be in grams is equal to our mass. So how I'm getting the units of grams is, where can I put this? So as a reminder, for percent mass by mass, in order for this formula to work out, the units in the top have to be the exact same as the units in the bottom. So when I rearranged all of this, so when I took 0.5% and divided by 100%, the percentages canceled out. Actually, I'm going to use a different color than that. Okay. And then what happened in the next step here is I multiplied by 100 grams. So because there's no units on this 0.005, but we still have the units of grams, but there's nothing else to cancel it out. That's why the units are grams. All right. And then for significant digits, this has one significant digit, so my final answer needs to have one significant digit in it. So that's good. So this is 0.5 grams of phenolphthalein is what we would be weighing out. I think that's how you spell it. Phenolphthalein. Let's see. Yep. All right, now since I've already described up here how I would prepare a solution, I'm not going to do that again. I think you get the point of how you would describe how to make a solution if you're in the lab. All right. How many grams of glucose would we need to prepare a 2-liter solution of 2% glucose mass by volume? All right, so let's write out our givens. So volume, that's 2 liters. And then we have our percent mass by volume is that 2%. And we are looking for our mass of our solute, because glucose can dissolve in water, and we're assuming that water is our solvent. So as a reminder, percent mass by volume, that's going to be your mass of your solute in grams divided by your volume of your solution, which that is going to be in milliliters, times by 100%. So looking at this equation here, we're going to have to convert liters into milliliters. Now, in previous lessons, we have gone from milliliters to liters by dividing milliliters by 1,000. So in order to convert liters into milliliters, we need to do the opposite. We need to times by 1,000. So if we times 2 by 1,000, that gives us 2,000 milliliters. So you could do the conversion like how I just explained, or you could use the metric conversion line, which is shown in a couple of my previous videos, so you can go back and look at that if you really want to. Okay, so let's figure this out. So percent mass by volume, that was the 2%. Mass of the solute, we have no clue. Volume, 2,000 milliliters, and we're timesing it by 100. So again, I just like to isolate the fraction first by dividing by 100%. Then this is going to give us 0.02. Equal to mass divided by 2,000 times both sides by 2,000, since 2,000 is dividing into the mass. And for an answer we get 40, and since this is our mass of our solute, it's going to be in grams. So 40 grams is equal to mass, and looking at my numbers, both of them are in 2 sig digs, so my final answer needs to be in 2 sig digs, which it already is. So 2 grams of glucose.